Swayam Prabha. Digital India. Educated India.
Namaskar. You have stepped into a course that is going to change the way that you look at data. Not just how you analyze it, but also how you communicate it. My name is Nivid Desai. I serve as the Program Executive at Writing Studio IIT Gandhinagar. Welcome to Writing for Data Science. This course is at the intersection of analysis and communication. As all of us know, data analysis is not just about coding and models. It is about solving real-world problems. And that is exactly why every single thought that goes into solving those problems needs to be communicated. And not just to one audience, across multiple stakeholders. That is where this course comes in. This course prepares you with the foundations of writing, especially curated for data science. We will discuss audience analysis, critical thinking, logical reasoning, as well as storytelling that is native to data science. So join me on a journey at the intersection of numbers and narratives. I'll see you in class. Namaste, hello and welcome to Writing for Data Science. My name is Nivid Desai and we are on a journey to explore the interesting intersections between numbers and narratives. In the last class, we began a new module, critical thinking and logical reasoning within data science. The last class was all about gaining insight into what we mean by critical thinking. What does it even mean? Why it matters? What are its components? And how do we develop a habit to become better critical thinkers? Today's class is about that second half of the title of the module, logical reasoning. It is along the lines of critical thinking, but it has its own nuances as well. So, let's spend today's class trying to discuss the elements of logical reasoning for data practitioners. Just like the last class, we will begin by discussing what do we even mean by this term? What is logical reasoning? Logical reasoning is the process of using structured, step-by-step thinking to move from evidence to conclusion. In data science, it is what helps us write arguments and insights that are coherent, credible, and defensible. Writing in data science is not just about presenting data, as we discussed in the previous class. It is also about constructing a chain of logic. What does this chain look like? It is just made of questions, just like the last discussion. What does the data show? What conclusion are we drawing? Why does that conclusion follow from the data? These are all important questions that help us make our insight as logically sound and consistent as possible. A lot rides on the kind of analysis that we offer to the decision makers. This is why data-driven insights help us become better logical thinkers. Here's an example. This is the data point in question. 60% of the customers who receive emails with product suggestions make a second purchase. So, the logical conclusion would be email recommendations are likely effective because customers who received them had a significantly higher repeat purchase rate than those who didn't. This is the kind of simple logic that follows from the data point to the conclusion. This is logical reasoning. It helps us connect the output, the outcome of your entire analysis with the data that we began with. Here's a quick reflection spot for you. Try to think about why is it important to show how your conclusion follows from the data and not just what the conclusion is. If you just offer insight, wouldn't that be enough? That is what your job is at the end of the day. But in order to make your conclusions more reliable, why does it have to emerge from data? Think about it. Maybe your gut instinct would be the right answer. Let me now lay out for you why logical reasoning even matters. Why should we care? In data science, we are often communicating insights to help others. We can help others by making decisions, changing strategies, allocate resources. All of these are tasks that we are aiding others in doing. Without strong reasoning, your writing may sound impressive, but it may lead to poor assumptions, faulty policies, or, worst of all, misinterpretation of evidence. For example, claiming that users prefer our app's new feature because usage increased last week. This may sound right. It's a very impressive statement to make, but without checking for other variables, like a promotion, for example, it is flawed reasoning. You cannot lead with the data and arrive at that conclusion without any flaws. Here's a quick exercise for you. Remember, just like critical thinking, logical reasoning is also a muscle that we build within our mind. Let's try to test it as much as possible and make sure that we track our data all the way to its conclusion. You notice a spike in website traffic. You can write one incorrect assumption. Think about what may be a hasty conclusion to make that may take many things for granted. And you can write one cautious explanation that takes the data into account and then tracks it all the way with logic to arrive at the conclusion. Now that we've understood why logical reasoning matters, why should we even care? Let's arrive at the core elements of logical reasoning. First of all, there is a premise. A premise is a fact or a piece of evidence that you begin with. It should be verifiable and relevant. Then there is the inference. An inference is a conclusion drawn from one or more premises. It should be logically connected and not introduce any unsupported assumptions. Speaking of assumptions, the third one is assumption. An assumption is something taken as true without proof. For now, good reasoning identifies assumptions clearly and tests them wherever it is possible. Then there is the conclusion. The conclusion is the final point that your reasoning supports. It should follow logically from your premises and inferences without adding any leaps. By a leap, I mean that you are reaching to arrive at the conclusion by eliminating some steps of logical reasoning in the haste of arriving at the perfect conclusion that may or may not be correct. Here's an example. Let's look at the premise. Data shows that 68% of users who cancelled their subscription in the last 3 months had not used the product in the 14 days prior to cancelling. What can we infer from this? We can infer that a lack of recent activity is a strong signal that a user may be about to churn. What assumption are we making? The assumption is that users who are inactive are disengaged, and disengagement leads directly to cancellation. Mind you, this is not proven. We are just taking it as true for now because it fits our theory. However, when we arrive at the conclusion, these things have to be verified. These things have to be backed by evidence. The conclusion then reads that to reduce churn, the company should target inactive users with re engagement strategies. such as emails, push notifications, or special offers before day 14 of inactivity. Because after day 14, they just end up cancelling. Now, just like we had structures to think about critical thinking, there are also patterns that we can develop as a habit for reasoning. Let's look at two of the main patterns of reasoning: deductive reasoning and inductive reasoning. Let's first look at deductive reasoning. Deductive reasoning moves from general to specific. If the premises are true, the conclusion must also be true. That is the rhythm in which deductive reasoning moves. For example, here's a premise: all users who enter valid data get access to the dashboard. Premise 2: user A entered valid data, so the conclusion is that user A will get access to the dashboard. It follows, right? Logically, if premise 1 is true and premise 2 is true, 2 plus 2 equals 4. That is the kind of logical reasoning that deductive reasoning treats us to follow. Let's now look at the second part: inductive reasoning. Inductive reasoning moves from specific cases to general conclusions. Mind you, it is probable, it is not certain, so the conclusion should be carefully worded. This is where language and writing play a crucial role. For example, the observation can be that users who click push notifications tend to engage longer. So, you may derive an inductive conclusion saying push notifications may help increase engagement. Did you see what I did there? It said may help. This is a possibility. It is a probability. You can probably quantify the probability as well. But it is not a certain assertion. You cannot guarantee that it will help increase the engagement. It just may, because it is not based on data, it is based on observations. Is this faulty though? Is this a faulty form of reasoning? Not necessarily. There are many things that you will find across our journey of exploring data through logical reasoning and critical thinking that not everything can be deduced, not everything can be quantified. We must also rely on our instinct, on our observations to make conclusions that are humane, not just correct. But there is such a thing as faulty reasoning. Here's how we can avoid it. Faulty reasoning makes your writing misleading or untrustworthy. Even in well written sentences, logical errors can undermine your credibility. Common issues like jumping to conclusions, assuming causation from correlation, ignoring alternative explanations, using emotional or biased language in the place of logic, all of these are examples of faulty reasoning. I know there might be some terms which might be new for us. Don't worry, we will explain them later on as the course moves forward. For example, causation, correlation, alternative explanations, emotional language. What do we mean by these things? Wait for it. We will discuss them as the module progresses. But for now, here's an example of faulty reasoning. Our sales increased after we launched the new feature. So, the feature caused the growth. This is one way of looking at inductive reasoning. Maybe it did. But maybe it was the holiday season or a discount campaign. There may be multiple factors that affected or even caused that growth. You can't just simply pinpoint on the feature as the success story behind the growth. So, quickly then, here's a reflection. What's a time when somebody gave you a confident answer but forgot to check for other explanations? You can take an example from your professional life or from your personal life. Like we discussed in the previous part, critical thinking and logical reasoning are not just technical skills, they are human skills. I'm sure as we are having this conversation, there may be many things going on in your mind that are relating more to your personal life than your professional life. Let that convergence happen. Let those kinds of stories come together. It will help us understand both critical thinking and logical reasoning as core human skills beyond their technical applicability. As we end today's lecture, I want to underline one core principle that will help us cement our understanding of both critical thinking and logical reasoning. Both of them help us achieve clarity in our thoughts. And clear thinking equals clear writing. Logical reasoning gives your writing the strength and clarity. Without it, your writing may be full of claims but empty of meaning. With it, though, even complex data becomes trustworthy, persuasive, and actionable. Writing is not a script that you perform after thinking, it is a tool that you use while thinking. Logical reasoning is the framework that keeps your writing structured, critical, and intelligent. To close today's entire class and discussion, here's a little exercise for you. Choose a recent idea that you've explained to someone. Break it into a clear premise and inference, a stated assumption, and a careful conclusion. It'll help you exercise that muscle for logical reasoning that is all too important, just like the muscle for critical thinking from the last class. So that was it from my end for today's lecture. We were discussing the early days, the baby steps of logical reasoning. In the next class, we will look at both critical thinking and logical reasoning through a much finer, a much more detailed lens. More mind maps, more frameworks, and more mental models await as this entire module progresses. And I hope that I'll see you there for those discussions. Until then, stay curious, keep learning. Thank you so much for joining me today. Namaskar.